Okay, welcome back on our wonderful journey of C++ and the STL. In the last video, my brain kind of freezed and I couldn't for my life uh, remember how to do. I was talking about the iterators and I will talk more about the iterators today, but the thing was I tried to do a reverse and as soon as I ended the video, I just, of course, and it's really makes sense. So we have to do something called a reverse iterator, because so this is backwards and this is forwards. Let me try to explain. Have a look at this. This is a iterator for a stud vector of movies. And I mean, when we iterate over an array using a regular for loop, we do in the end I++, right? We iterate forward plus. But if we were to write a for loop and iterate backwards, we can't do I++, right? We need to do I minus minus. So I mean that's why we that's what the reverse iterator does, because the iterator classes, they are small abstractions of pointers actually, and therefore we need two different, one class that will do the plus and this will do the minus, of course. Anyway, now you know that, and it totally makes sense. Okay, so let's do accumulate. Let's talk about accumulate. I have added a price, a property price. So each of these movies, or what we should call them, I mean some of them aren't even, some are TV series, but they all have a price. So let's figure out how can we sum all these prices up. Let's say we want to accumulate all the prices, as in what would it cost you if you were to buy all these fantastic movies by Dwayne Johnson. And typically we would do a for each loop. I'm not going to do it, but I'll just show you. We do a for each loop, and we have, you know, a variable, a total, and we start it by 0, and in here we add it and so on. There is a problem with overusing for each, because I mean, for each there is no semantic meaning in for each. Actually, there is a fantastic semantic meaning. I mean, go through each, but there is a special function called accumulate. Let's just uncomment this. Accumulate. So I mean, listen to it. Accumulate. Ackumulera in Swedish, tally, or I mean calculate the total. So what we do is we have this result, and we say accumulate, and as usual, as always, we have these begin and end. I will talk about it soon a little more. I mean, right now it feels like, oh, we're always using begin and end. Actually, we will not always do that, because we will see when we are finding things. So far it's just okay. We always need to add these iterators. Here, what's this? This is the variable that we want this algorithm to start tallying with. It would begin with 0. You know, when I created a variable called result, I set it to 0, and then we added it up for each. Because the thing is, in all these functions, all these algorithms, most of them, there is a for loop, for each loop. We don't see it. So they will do a for each loop, and they will call this function. I mean, for each movie, they will call this function, and as you can see, it will always send in the current total, and we will then return a new total. So that will be the result plus get price. So as you can see, it's really the same. And this way we do get, let's see. Oh, okay, 696. Great. Let me see. No, there it is. Okay, there it is. 696. Great. So that's seems yeah, that's probably right. Okay, so that's one thing of doing it, and I mean, you could of course do some filtering as well. You could, I mean, if blah 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 blah, you would return just a result. If you just want to count, you know, some certain movies or something. So it's, I mean, we could do if statement here if you want. Yeah. Okay, so the next thing is sorting. Yeah, let's sort. And sorting, you will see that almost all these these algorithms work the same way. And when we sort them, we will, of course, we will start by, guess what? Guess twice? Guess, I mean, guessing once will suffice. Of course, we start with the begin and the end. From where to where? I mean, it is possible. It might not seems like a valid use case, but as you can see, it is possible to sort just a fraction of a total vector or so. As I said, I will show you when we are not using the end and the begin all the time. So, okay, let's then, I mean, sorting. There are, of course, different sorting algorithms. I bet you have heard of shell sort and quick sort and bubble sort, maybe. One thing we could be sure of is that the creators of the STL, they are using pretty advanced and performant sorting routines. So I mean, we should never ever write our own sorting routine. When sorting, in general, it's all about comparing two items at a time and maybe swapping these. And you know, the algorithms decides when we are finished and how many laps to go and so on. But that's kind of the thing. So what we will need to provide is a function which will be called whenever the sorting routine needs to compare two values. So we will provide a routine that will compare two items like this. I always call it item 1 and item 2, but that's me. And what we will do is we will just, I mean, we will return if the first one is larger than the last one. That's it, basically. And after this, we could print it out. Yeah. Let's see. Yeah, okay. So we sort. And we provide, as you can see, this is not the sorting routine. It's not a for each. I mean, there is a totally. It's not. It's a more advanced algorithm. So I mean, this won't be called for each item. It will be called whenever the sorting routine feels like it. And it will provide, now I need to compare this and this, now I need to compare this and this, now I need to compare this and this maybe, and finally it's satisfied and sorted. So let's give it a try. and see what it says. Oh, okay, so I have some weird, I don't know, something about the breakpoints. Probably need to restart something. Anyway, so let's see. It really has, it's sorted now. So fast STY. So it's sorted. That's great. I mean, we can, of course, always. I mean, we could sort it the other way around. So we could do item 2 less than item 1, or we could, I mean, just chain list, and it will sort the other way around, of course. Okay, so yeah, let's do that. Just once more quickly, and okay, so it's sorted the other way around, as you can see, and as you can guess, it's pretty easy to add, you know, secondary sorting if they are the same. I mean, this is code. We could do if statements. So if they are the same, we could sort on the year, or you know. All right. So that's sorting. Let's now go to finding. I think. Let me just see. Yeah, finding. Finding them is one of the. I mean, it's not that. How should I put it? It's one of those things that might not be that intuitive, to be honest. But it's not all that. I mean, it's not completely hard. It's no problem trying to find a single one, but when we're trying to find multiple and we need to iterate all of these search results, you will see there is a bit. Not the problem, but we kind of need to get used to a certain way of coding. Let me just open up. Okay, so let's try to find. Okay. Okay, so I have no numeric ID or anything, so let's not do this. Let's say that the user enters a movie for us to search for, and it enters no, actually it enters a year. No? Okay, it enters a price then. Okay, I'm just looking for something that will give multiple results. So if we search for 200, list all the movies that cost 200, then we will get 2. Yeah, and we could of course also list just the ones that cost less than. That will be great. Okay. Price is then 90. Okay. So what I want to do now, I want to list all movies. All movies costing less than 90, less than the price. And as you can see, it could be, I mean, in this case, it could be multiple, there will be only one, doesn't matter, it will be the same code anyway. So the thing is, this is really, I mean, it's really clever. When you do some kind of searching in other languages, I mean, you might expect to have a function which will return, you know, like a new vector. Wouldn't that be great? Let me get back to these ones in a minute. Okay, so it's not even the correct code. I mean, wouldn't it be great to do something like stud find? Actually, we're going to do something called Findif. But it would be great to, I mean, say where we are searching for things, of course. And also we will provide a function, a predicate, which will return true or false if it's found. So I think so far I don't think you have any problem following along. So we have this, and we will say return. It will return true if it's a match. So it will return true if, actually let's not use this variable yet, because we're not talking about lambdas and what is called closure. Anyway, where m dot get price is less than 90. Okay. Now you would maybe expect or hope to, get a vector or something, and we could then just iterate over that vector. It's not that easy, because if you the thing is, if Findif were to return a vector, there would have to be some allocation, right? And we don't want that, because in most programming languages, I'm gonna there are the streaming concept in like LINQ or streams in Java, so they won't create copies, but they would stream it. They would yield. What we do here is we are yielding one at a time. So it's not completely fair to say that other languages can't do this, but in a way it's let's be honest. Other languages abstract it more than C++, so we have to do it like this. All right. So we will get, what will we get? I have no idea, so let's just say auto. So typically we do this. Okay, so what we'll find if return, oh god, it will return, no, we have seen this before. Have a look, stud vector movie iterator. So it seems like this could work. The thing is, remember this, an iterator is actually nothing but a pointer. So the iterators we have seen so far have been plus plus or minus minus. The reverse iterator and the forward iterators just go to the next one. In this example, we can't use, actually let's say that with this one also cost 88. No, sorry, that was 82. Which is a bargain for Young Rock. Anyway, let's be okay. The thing is, if when we do the first such, we will get an iterator. And what is an iterator? It's just a pointer. So the pointer will point to this one, right? So IT will point to this one. And the problem is, if we then just do, the plus plus on the iterator, or we just, we can't just increment it, because incrementing will put it to this one. And that's not correct, because what we want to do is have a look at this. This is more how we write the code. Now I need to, okay. Now we're going back to this one. So typically we will have two variables. We will have an I variable typically, because I mean that's typically what we use for the iterator. At least I do, and we also have an end like this. So I have two variables, and what we do then is we create a while loop, because that's what we. I mean, this is a loop, right? We want to loop all movies costing less than the price. So what we do is we say as long as I not equals to end, and as you can see now we have already evaluated the end. So like this. I mean, we don't have to. You don't have to use this variable. This one is the the variable, so to speak, that we will increment and iterate. Anyway, what we do now is this. Yeah. So we say like this. So as you can see, sorry. And now we will, of course, use these variables, right? So follow me now. First of all, the iterator I will be here. This is I. And you know, and is always and will point to beyond the last. Anyway, as long as we have not reached the end, we do a find if, and we start at the I. Oh, great! We start at the I. Perfect, and we go no further than the end, and we apply this to this one and this one and this one, and we have a match. Yes, we have a match. And after, I mean, find if will return on the first match, and therefore after, when we get to this line, hello, I will be I will be here. So I will point to this. Great. And we need to always check if we have found a match, and it will always be. The thing is, you can copy and paste this code and you can enhance it as well, but you know, this will also come natural when you start using you know, find and these STL regularly. Anyway, so if we find anything, then we might do whatever we want. So we print it or whatever. So I'm going to print it, and now then, you know, the I, as I said, this is an iterator of a study vector movie, and an iterator is, I mean, it's a glorified pointer, more or less. So to get to the actual object, I mean, this is one of the things when it's better to use objects instead of, we don't have to dereference it. So instead we use the arrow, so you can see the I is a pointer. It is actually, it's not a pointer, it's an iterator, but it overloads the arrow operator. So we could do this and get to the, you know, the object it points to, in a way, like this. Okay, so what has happened now is that we will print this. All right, and if we have found it, we do, and this is kind of, you know, it looks like Weird, but it's not. I mean, how could we do plus plus on an iterator? But as usual, I mean, in C++, there's so many overloads for operators, so the stud iterator class is overloading the plus plus operator, and therefore what this will do, I mean, it will not advance just, you know, a pointer, the size of the pointer. It will advance the size of whatever it's pointing to, a movie. So, I mean, after this line, the I will be, let's see, here. Cool. All right, so I is here. And we are at the end. Actually, I have, let's do this. Yeah. Okay. So now we are at the end of the loop, and we will go up yet another and evaluate this again. So as long as I is not the same as no, it's not. So we will enter this loop once again, and as you can see, here's the beauty. Here's the beauty. We will call findif once again. But how will it know that we want to get the second one? That's, I mean, we have advanced the iterator. So the iterator, the I, is pointed to this one. And this is where we start finding. And now I hope you start to see the beauty of this. I mean, we just you know, routinely add them all the time, but it feels like we just routinely add them. Just, oh, it's always the beginner student. No, it's not. This is a case where I hope you can see the beauty of iterators, even though it might just be a pain in these kind of and actually in C++20 in ranges it will be nicer. I will talk about that briefly, I think, in another video. Anyway, so what will happen now is when we do the findif, it will start here, and therefore it will find this one. And we will get to this, and this one is what will be printed, right? No, sorry. And then it will increment again, and after incremented, the I will be down here, and all of a sudden when we get up here, it will, you know, we have found it. So that's the thing. And as you can see, it's, of course there are, I mean, in many languages, this kind of streaming thing where we get just one item at a time. I mean, it's so efficient, and as I said, this is not a case where C++ is the only one capable of doing it. I mean, it's in Link and so on. They all work this way with the yield keyword in C# and so on. Anyway, let's try it then and make sure that it works. Sorry, I need to focus. All right. So hopefully, okay. So we really got 2 items. So we got these 2, and as you can see, this is. I mean, it's so efficient. When we start using, and I mean, it doesn't have to be a lambda, it could be a function, which we could reuse, and so on. So there are a lot of things, there are a lot of more things to talk about. Actually, I'm trying to find a valid example, not so advanced, for so-called functors. We could have objects working as a function in a way, and it's I will give you another video on that. It's really cool. So you can do a lot of cool things. Anyway, let me just see if this is all for today, or if I have missed something. Okay, so we talked about sorting, we talked about accumulating. Now we are also able to find things in our container. And as I said before, and I repeat it, we almost always use vectors. There will be a video on maps, and I will also talk a little about transform, and I will also talk about the cool function objects, I think. Anyway, this is all for today. See you soon again.